knowledge representation would be our brain, right? How we store information in our brain, the structure of our database, what we store in our head. That part of artificial intelligence deals with that area. Then we have the reasoning, and the reasoning is just a bunch of logical formalisms that allows the software to make inference, to derive facts from other facts, and actually come to conclusions, right? Then we have natural language processing. This is very interesting. So the whole idea with natural language processing is to try to understand for the software what is the meaning of a sentence. And I found this example, and I quite like it, because it says, I eat spaghetti with chopsticks, I ate spaghetti with meatballs. If you look at the tree, so the natural language processing is going to be a tree like this. So this is the subject, this is the predicate, this is the verb, this is a pronoun, this and that, right? So this is how we do this thing. So the tree is exactly the same. The meaning is completely different. In here, I'm using chopsticks to eat spaghetti. And here, together with my spaghetti, I'm eating meatballs. Because we have given it something like this. Here, there will be under food, there will be meatballs. And then the software knows that meatballs is a type of food. But maybe here, in another portion of the tree, of the graph, I have tools that I eat for eating. And under tools that I eat for eating, I will have chopsticks. And therefore, combining all these things, the software is really able to understand what is the meaning of a sentence, and then also the reasoning and so on and so forth. Machine learning, and I will call it again machine training, deals with training the knowledge model that we've built to do a particular specific task, and that will be your neural network and your supervised and supervised learning that we will talk about afterwards. There is a whole discipline of study dealing with how software make plans to complete tasks. So this is a robot. This is an industrial robot. We'll talk more about them later on. And the whole idea of this guy has 3 blocks, and the idea is like, I want to pile C under B and B under A. And it's a very interesting problem. It looks very simple for a human, even a small child can do it. But first it involves seeing where the blocks are located and how are they piled and how are they organized. And then I have to make a plan. If I want to have A on top, then this is fine. But if I want to have A as the first block, then I have to first move B. Perception, we briefly talk about it. Perception deals with the ability of the software to communicate. I say software interchangeably with agent or AI, or I mean, to me it means basically the same. I say the only portion that is different is the robotics. The rest is just software, really. So that's why I use these terms. So perception deals with image processing. How the robot is going to perceive how the blocks are organized. How is this going to make this, plan based on that organization? But the first thing that they need is to see how is that my problem laid out. And robotics is very clear and very obvious to everyone, right? It's how the thing is going to move, and how it's going to run, and how it's going to do things.